My name is Travis Miles.
Daphne Monroe.
Josh Kohut. So you all may have experienced the cold pool yourself. Sometimes if you're down at the beach in the summer and you're getting really nice weather, nice winds consistently from the south-southwest, you might be out swimming one day and surf temps are great. They're around mid-70s, sometimes even upper 70s. Then the next day, doesn't seem like the weather changed much, but all of a sudden the surf temps dropped into the 60s or sometimes even as low as the upper 50s. That rapid change in temperature that you may have experienced, that's the cold pool. The cold pool occasionally comes all the way to the beach.
And what you're actually feeling is the cold pool coming up to the surface. Like the atmosphere, the coastal ocean changes temperature seasonally. In winter off the mid-Atlantic region, it's cold top to bottom. However, in summer, the ocean's surface warms up rapidly. You end up with layers of warm water overlying cold remnant winter water that's left over. And it persists throughout the summer. It's found kind of between Cape Cod, Massachusetts to the north and Cape Hatteras, North Carolina to the south. That cold feature, it sticks around through June, July, August. Once you start getting fall storms that can come through, nor'easters or even tropical cyclones, they can actually mix up that cold water into the surface of the ocean and start to break it down. We have one of the strongest top to bottom temperature differences in the world, which can affect how the ocean might mix when you put structures or when you blow wind over that particular ocean. The cold pool is really important for marine organisms. It's a habitat. It also has a lot of the nutrients that those organisms rely on to survive.
Along the mid-Atlantic, cold pools there increases the productivity overall, and it supports some of the most lucrative fisheries in the world, some of the most sustainably managed fisheries in the world. We've got species that live off the coast of New Jersey that you wouldn't expect to live here because they need cold water. And it's that cold pool that provides the habitat that allows them to live here. Summer flounder, winter flounder, yellowtail flounder will follow these currents, and they'll use these seasonal aspects of the cold pool as cues for things like spawning or migration. Likewise, shellfish on the bottom will use the stable summer period to build up reproductive resources, and then in the fall, when it breaks down, they'll spawn. Alteration to the timing of when the setup and the breakdown happens, or how stable that summer period is, could have important implications to the commercial stocks in the region.
We understand a bit about the cold pool. We understand a little bit about how offshore wind has impacted seasonal stratification off the European coasts, but we don't know exactly what's going to happen when wind farms are deployed off the mid-Atlantic coast in the specific conditions of the cold pool. And so what we aim to do with this paper is just to lay out what we know about the cold pool, what we know about offshore wind impacts on oceanography off of Europe, to try and lay out some priorities of where we need to focus our research so that we can answer these key questions of basically what's going to happen to the ocean when offshore wind is deployed off our coast.
Processes that may mix the ocean rely on currents or the ocean moving past a structure. The faster that ocean moves, the more likely you're going to have mixing. You can have significantly more mixing with just a little bit of ocean movement. Understanding how fast the ocean moves in our region relative to how fast the ocean moves in other regions where some of this research is done is super, super critical. Tides in Europe move very fast. In the mid-Atlantic region, we have relatively slow currents unless we have storms come through. So what we're curious about is how those storms may interact with structures and cause mixing throughout the season.
It raises interesting research questions that we have, because if you're in a place off the coast of New Jersey, for example, or New York, the winds are really important to understand the mixing, and the turbines are not just going to influence by the structure in the water, but they're also going to impact the wind that could potentially be there to drive the mixing.
The cold pool is a dynamic feature. It doesn't always end up with the same strength every year. It's not always in the same place every year. It requires a lot of ocean observations to capture it and to understand it. And it's a difficult thing to model. So a lot of work is needed to really look at those details and understand how it may change in the future. Whether these wind farms are going to act like a sieve and allow water and flow to just pass through them, or whether they're going to act like an egg beater and mix that water as it goes through. We're still trying to understand that in some detail based on some of the newer turbines that are proposed for the region. So there's this balance of all of these different physical processes that we need to understand.
We've identified 3 basic areas that we need to understand better. One, we need to understand how much overlap there is between the offshore wind energy areas that are targeted for development and the cold pool. The second thing that we don't know is what level of stratification is going to be impacted by offshore wind. We know that when currents move past a structure, there's mixing that's induced. But how fast those currents move and how big the differences in temperature from surface to bottom will impact how that mixing actually happens. And then the third piece, we've got to relate that to the seasonal evolution of the cold pool off our coast. How do those thresholds match up to what the cold pool's doing in the spring, summer, or fall? Because the cold pool looks different in each of those seasons, and it can be different even from year to year. And so one thing that we need to understand is how does the location of the cold pool relate to or overlap with the location of offshore wind farms?
So the tools exist, and I think the next step is really to apply those tools to this new and exciting area of research. We want to have fisheries as well as green energy able to coexist and not have impacts, significant impacts on each other. That's I think something we can all strive for.